Hi everyone, my name is Mubashir Shamim from the CS department of Shri Venkateswara College of Engineering. Today we're going to discuss about enforcing data integrity, exploring relational models, constraints and database schemas. Introduction. The relational model provides a framework for ensuring data integrity through constraints and schemas. This presentation explores the key concepts and principles in enforcing data integrity in databases. Relational model overview. The relational model organizes data into tables with rows and columns. Enforcing data integrity through constraints, it ensures asset properties for transactions and supports referential integrity. Domain constraints. Domain constraints define the allowable values for attributes, ensuring data integrity by restricting input to a specified domain. They are enforced through data types and check constraints. Entity integrity. Entity integrity is enforced through primary keys and ensures that each row in a table is uniquely identified. Violations are prevented by the unique constraints. Referential integrity. Referential integrity is a property of data stating that all its referentials are valid. In the context of relational database, it requires that if value of one attribute column of a relation table references a value of another attribute either in the same or different relation, then the referenced value must exist. For referential integrity to hold in a relational database, any column in a database table that is declared a foreign key can only contain either null values or values from a parent table, primary key or a candidate key. In other words, when a foreign key value is used, it must reference a valid existing primary key in the present table. For instance, deleting a record that contains a value referenced to by a foreign key in another table would break referential integrity. Some relational database management system can enforce referential integrity normal either by deleting the foreign key rows as well as to maintain integrity, or by returning an error or not performing the delete. Which method is used may be determined by a referential integrity constraints defined in a data dictionary. Database schemas. Database schemas is a logical representation of data that shows how the data in a database should be stored logically. It shows how the data is organized and the relationship between the tables. Database schema contains tables, fields, views, and relation between different keys like primary key, foreign key. Data are stored in the form of files which is unstructured in nature, which makes accessing the data difficult. This to resolve the issue, the data are organized in structured way with the help of database schema. Database schema provides the organization of data and the relations between the stored data. Database schemas defines a set of guidelines that controls the database. Along with that, it provides information about the way of accessing and modifying the data. Integrity constraints. Integrity constraints such as unique check and not null ensures the accuracy and reliability of data in the database. They play a crucial role in maintaining data integrity. Normalization. Normalization is a process that reduces redundancy and dependency in data, leading to more efficient and integrity preserving database design. It involves eliminating data anomalies. Enforcing data integrity. Data integrity is the opposite of data corruption. The overall intent of any data integrity technique is the same, ensuring data is recorded exactly as intended, such as database correctly rejecting manually exclusive possibilities. Moreover, upon later retrieval, ensuring the data is the same as when it was originally recorded. In short, data integrity aims to prevent unintentional changes to information. Data integrity is not to be confused with data security, the discipline of protecting data from unauthorized parties. Any unintended changes to data as the result of storage, retrieval, or processing operation, including a unexpected hardware failure and human error, is failure of data integrity. If the changes are the results of unauthorized access, it may also be a failure of data security. Depending on the data involved, this could manifest itself as being as a simple pixel in an image appearing a different color than was originally recorded, to the loss of vacation pictures or a business critical database, to even catastrophic loss of human life in a life critical system. Best practices. Best practices for enforcing data integrity include regular maintenance, documentation, and collaboration between database administrators and application developers. Conclusion. The relational model provides a robust framework for enforcing data integrity through constraints and schemas. By understanding and implementing these principles, organizations can ensure the accuracy and reliability of their databases. Thank you. Have a nice day.